Okay, so it's been a minute since I've made a video, but we have a CBA coming up, so I wanted to go over this review, okay? Especially for some of us who maybe haven't been back from the Thanksgiving break yet, okay? Now, when we're talking about number one, okay, one of the biggest things we have going on here is the x equals -3. So when they say evaluate the expression, what they're really telling you to do is solve. And the reason why this piece of information is important is because we're going to be substituting our x with the value of -3. Okay? So we're going to rewrite this as 3 times 2 squared minus 16 divided by, in parentheses instead of x, -3 minus 1. Okay? Now, that's really important. Another thing that's really important is understanding what process we're supposed to be following, okay? We are following PEMDAS. That's going to be parentheses, exponents, multiplication, division, addition, and subtraction. And we're following it in this order so that we don't make any mistakes, okay? So the first thing that we're going to do is work on what's going on inside of our parentheses. And what's going on inside our parentheses is -3 minus 1. Now that's going to give us a -4, and I'm going to write that right here. I'm literally just dropping everything else, okay? Divided 16 minus sign 2 squared times 3. So we solved our parentheses, but now we have exponents. So this is going to be 2 times 2, which will give us 4. And then I drop everything else. Now, even though in PEMDAS it says multiplication before division, when we have multiplication and division in the same expression, we just work from left to right. So that's exactly what we're going to do here. 3 times 4 will give us 12, and -16 divided by -4 will give us a +4. And when we add those two numbers together, we get the answer 16, which is this answer here. Going to number 2, okay, evaluate, again it means solve, the expression 5 plus 4 squared minus 6 divided by 2. Cool, let's do it. So this is my checklist. I don't have any parentheses, but I do have exponents. Now this is not 4 times 2. This is 4 times 4. The exponent tells us how many of our base we have. So we have 2 of those 4s that are being multiplied. And 4 times 4 gives us 16. I'm just going to drop everything else. Now, going down our checklist, I see that we now have division. And that division is -6 divided by 2. And -6 divided by 2 will give me -3. 5 plus 16 will give me 21. 21 minus 3 will give me the answer of 18, and that is going to be your answer. Next one is not hard, again, the variable tells us how many of that base number we have. So here they're saying we have 2 of those 3's being multiplied together. 3 times 3 times, we have 4 or 3 of those 4's being multiplied together. 4 times 4 times 4. When we look at our answer choices, I see that there's a 2 right here. And I see that there's a bunch of 2's right there. I'm not sure where they got those 2's from. Potentially from mixing up our exponent with our base number. But I'm going to go ahead and get rid of those answer choices, because that's not what we're going to get when we expand these. So now it's a matter of finding what works. If I look at B, 3 times 3 works, but they're adding here. Are we adding? No. So that's why this one won't work. Answer here is C, because we have 3 times 3, 3 times 3, times 4 times 4 times 4, times 4 times 4 times 4. All right, let's keep going. All right. Which 2 expressions are equivalent? So what's happening here is distributive property. I'm going to be giving this number out to 8 and to my negative x to be multiplied. Okay? So if I distribute my 6 to my negative 8, that could be written as, I guess, what? Let's do this. 6 times 8. Now in the middle there is a subtraction sign, right? 6 times x. Excuse me. So if I look at this here and I drop it down, they're saying they should be equivalent. So if they're equivalent, they should be equal. Let's drop it down. 6 times x minus, or 6 times 8 minus 6 times x. Well, that's identical to me, so that works. But we're still going to talk about why the other ones don't work. This negative is really a -1. That has to be distributed, okay? We can't do anything with our 9 minus x, so we're going to distribute our negative to our 9 and our negative to our negative x. So now when I write it, it should be 7 minus 9 plus x. When I multiply a negative by a negative, I get a positive, and that's why it's plus x. Now these are considered to be like terms. I can still solve that. 7 minus 9 will give me -2 plus x. Here, we're still distributing that negative sign to our x and that negative sign to our -9. So this becomes 7 minus x plus 9. I can't do anything with this negative x, but I can do something with my 7 and 9. So I'm going to combine them because they are called like terms. 7 plus 9 will give me 16 minus x. Are those equal? No, they are not. Let's keep going. When I have a number multiplied by a letter, I think of it as peanut butter and jelly. This one's peanut butter, this one's jelly. What do? I stick them together. This is going to be 3x. Can't do anything with my +5, so I kind of just drop it. Here, I need to multiply my 3 by my x and my 3 by my 5. That's going to be, again, this distributive property. I get 3x plus 15. These are not equal. This one is 3x plus 5. This one is 3x plus 15. Close, but not really. Here, we really can't do anything at all. Let's assume we got rid of our parentheses and we wrote it as x divided by 10 plus 2. Well, that really becomes x divided by 12. Again, if we get rid of our parentheses there, then we get 2 plus 10 divided by x, which is 12 divided by x. These are also not the same. This is like saying 3 divided by 4 is the same as 4 divided by 3. That is not true. 4 divided by 3 is like 1.33, and 3 divided by 4 is 0.75. So these are specifically the reasons why those ones are not true, and this work here is specifically the reason why F is. Okay, let's keep going. All right. Number 5, which expression is equivalent to 4 times x plus 9 minus 15? Okay, cool. Shouldn't be a problem. I would have to distribute my 4 to my x to be multiplied and my 4 to my 9 to be multiplied. Which means, and this is, I'm basing how I'm writing this on my answer choices. You can see it's 4 times x plus 9, blah, blah, blah. 4 times x plus 9, blah, blah, blah. So that's how I'm basically going to decompose this as well. If I have 4 times x plus 4 times 9 minus 15, then let's see what happens. If I go to A, I go 4 times x plus 9 minus 15. Well, what happened to my 4 times 9? A can't work. For B, I can do 4 plus x plus 9. Are we adding? No. So that's not right. 4 times x. Okay, so far so good. Plus, so far so good. 9 times 4. 4 times 9, that could be the same thing. It doesn't really matter. Minus 4 times 15. Where are they getting that? That's not going to work either. 4 times x, good. Plus 9 times 4. That's the same thing. Addition and multiplication are interchangeable. Minus 15. Our answer here is D. Now for distributive property, for the next one, which is an example of distributive property, first and foremost, I need to know what distributive property means. And what I'm going to write for number 6, I'm also going to write for 7 and 8, and then I'll add more definitions. So distributive property means a number given out to be multiplied. I'm going to do the same thing over here. A number given out to be multiplied. And again, a number given out to be multiplied. That's called repetition. Also drill and kill. Also rote memorization. Now, associative property, this is when your groupings move. And by groupings, we mean our parentheses. And I'll do the same thing here. When groupings move. Commutative is when numbers move. Numbers move. Okay? So that's important for all of this, but let's go all the way back up to our number 6, okay? Awesome. So, which is an example of the distributive property? Well, okay. We have 7 times 34 essentially, but if we were to decompose that, and this is basically place value, my 4 is in the ones place and my 3 is in the tens place. If my 3 is in the tens place, then this really represents 30. So if I decompose this and I have 30 in parentheses, and in my ones place I have 4 in my parentheses, well, now I have to talk about what number is going to be distributed. In front of every single one of our parentheses is a 7, which tells me that's the number that's going to be distributed. I think I see it. It should be H. Now, F is close, but F is 7 times 3 plus 7 times 4. The 3 is in our tens place, and that's why it's 30. Okay? Now, go into the next one. They gave us an expression, or really an equation, because there's an equal sign, and they're asking us which property is taking place here. I'm going to look at my numbers. I have 18, 13, 7. 18, 13, 7. So I know my numbers did not move. I'm not distributing anything because nothing's being given out. But what I'm noticing here is my parentheses are around my 18 plus 13. And on this side, my parentheses are around my 13 plus 7. That tells me my groupings moved. So number 7, that's an example of associative property. For number 8, I'm going to look at the numbers. I have 8, 3, 2, 5. On the other side, I have 5, 2, 3, 8. So my groupings didn't move. In here, I still have 8 plus 3, and in here, I still have 3 plus 8. That will give me the same result. So my groupings didn't move. I didn't distribute any number to be multiplied, but I see here that my numbers changed places. My numbers moved, and that's why it's commutative. Let's keep going. All right, they want to know here which is a property or which expression is incorrect, okay? So we are going to focus on the wrong answer. This answer here has to do with what's called the exponent rule. And that is that any number to the power of 0 equals 1. So this ends up being correct. We are looking for what is incorrect, so we cannot use that answer. That works, so we can't use it. Negative 4 to the power of 3 is going to look like negative 4 times negative 4 times negative 4. Well, negative 4 times negative 4 should give me positive 16. A negative times a negative is a positive. Then 16 times negative 4, a positive times a negative will give me a negative, and 16 times 4 is 64. So this is true, and that's why I can't use it. C says negative 7 squared is equal to 49. Let's try it. Negative 7 times negative 7. A negative times a negative is a positive. This will give me 49, which is equal to 49. That one works, so that's why this is wrong. The one that does not work is going to be D. Again, it is not 3 times 2. It is 3 times 3, which gives you 9. 9 is not equal to 6. Okay, moving on. Number 10, sorry. We are going to be talking about prime factorization. Okay, we are breaking down these numbers into their smallest factors. So we're going to start with the number 160, and we're just going to keep on breaking it down. And we're just going to break it down by seeing if we can split it in half. So if I cut 160 in half, the factors I get are 2 and 80. If I continue to split 80 in half, the factors I get are 2 and 40. If I continue to split 40 in half, the factors I get are 2 and 20. If I continue to split my factors in half, then the factors I end up with are 2 and 10. And if I continue to split my factors in half, then I finally end up with 2 and 5. Now, 2 is a prime number because you can only get to that number if you multiply it by itself and 1. 5 is a prime number because you can only get to that number by multiplying itself and 1. So I'm going to circle all of my prime numbers. And then I'm going to count how many of that same number I have. I have 1, 2, 3, 4, 5. And if I'm writing that in exponent form, that means I have 2 to the 5th power, or 2 to the power of 5. I only have 1 5, so I only need 1 5. And that is your answer there. Moving on to number 11, it wants us to evaluate the expression. Evaluate just means we're solving. So first things first, we solve our parentheses. It's always PEMDAS. So this will give me 4 squared divided by 64 divided by, I'm dropping everything else down. Now I worked on my parentheses, but now I have this number in exponent form. So let's break that down as 4 times 4, which will give me 16. Then I bring everything else down. I bring my 64 down, my division sign down, my plus sign down, and my 4 times negative 6 down. Now, even though PEMDAS has multiplication technically first, when we're in this situation where we have division and multiplication in the same expression, we just work from left to right. So 64 divided by 16 will give me 4. 4 times negative 6 will give me negative 24. 4 minus negative 24 will give me negative 20, and that's your answer. All right, let's keep going. right, number 13. They want us to evaluate, meaning they want us to solve. So let's solve. All right, first things first, parentheses. 1 minus 8 will give me -7, and I bring everything else down. Then, according to PEMDAS, after the parentheses, I do my exponents, which is this one here. 3 times 3 equals 9. I bring everything else down. Then again, PEMDAS, I work from left to right. 63 divided by -7, a positive and a negative will give you a negative. That's going to be -9. I bring everything else down. -9 times 9 will give me -81 minus 6, which will give me the answer of -87. Whew. Okay. So, for this one here, we have a key, all right? And these are called algebra tiles. For every small plus sign, it means 1. For every small negative sign, it means -1. And for every long tile, whether it's positive or negative, represents X. And anytime you see this kind of stuff, the long tiles equals your variable, whatever that variable might be. In this case, it's X, okay? So let's think about what we have here, all right? I see 2 long tiles and both of them are positive. So if each one is X and I have 2 of them, then this represents 2X. If each one of these represents -1 and I have 3 of them, then I have -3. And because every single one of these are the same, that's exactly what I'm writing above every single one. Now, it wants us to write an equivalent expression, right? So we have 2x minus 3, but how many of those 2x minus 3's do we have? 1, 2, 3, right? How many groups do we have? 3. So I can write this as 3 parentheses 2x minus 3, and that's my answer. For 15, biggest thing here, keyword is quotient. Guys, quotient means that you are going to divide. Now, there's several different ways to show how to divide, but there's only one way that they're really looking for. So I'm just going to show you a few examples, and we'll go from there. Easiest one we can think of is 2x divided by 3. We can do 2x divided by 3. We can do 2x to 3, which is a ratio, same thing as a fraction, which is division. Or we can do 2x over 3. Now, based on this particular CBA review, okay, based on this specific review, even though all 4 of these are true representations of division, they want that one, okay? And we'll go into why. Well, there's going to be another question similar to this, but this is what they're going to ask for, okay? So that's how we're doing it. Here, okay, they want to see 2 equivalent expressions for the model. Well, I have 1, 2, 3, 4. 4 positives. I have 1, 2, 3, 4, 5, 6. 6 negatives. But remember, the long tiles equals variables. So it's not just negative 6, it's negative 6x. Now, if I just flip that order, then I have one of my expressions, plus 4, just like that. Now, when I start thinking about partitioning my 4 and my negative 6x, I can break those down further. And I can break it down as a 2 right here and a 2 right there. And I can break this into a negative 3x and into a negative 3x. Now, why is that important? Because I can take one of these 2's and put it right there. I can take one of these 3x's and put it right there. And I can take my other 2 and add it there. The reason why I'm only using one x is because I know I'm going to multiply it by 2 here. So I don't have to put both. Now, I can prove that that is equivalent really just by solving. If I did 2 times 3x plus 2, I distribute and I distribute, I end up with negative 6x plus 4, which is exactly what we have for our first expression. So that's how I know it's true. Okay, let's keep on keeping on. Okay, number 17. Not too bad. All right, we can get this one done. All right, number 17. Patrice cuts a piece of board 4 feet long from a board that is x feet long. So the reason why, even though that's on the same line, but I broke it up, is because those are two different things happening here. So I need to find a board, or I need to draw a board that is x feet. Okay? Then I'm going to go ahead and just cut. I'm just guesstimating here. It's not whatever. I'm saying this is going to be 4 feet. Sure. I'm going to cut 4 feet from it. Well, if I'm cutting 4 feet from it, I'm going to be subtracting that 4 feet from it. Now, they want to know an expression that can describe what's happening here. If you look at your x and your minus 4, that is literally our expression. This is x minus 4. For the next one we says Jan's, or Yuan's, I don't know, Jan's class collected 143 cans in a food drive. Okay, so Jan's class collected 143 cans. Doesn't matter why, whatever. But the class plans to sort the cans into n bags with an equal number of cans in each bag. An equal number of cans in each bag. That tells me I'm dividing. I'm going to get those 143 cans, and I'm going to divide it into, we don't know how many bags that's going to be, so in this case, into n bags. All right, let's keep going. Okay, here. Anytime you see an expression that says minus and in parentheses another negative number, you can't do that. There's something we have to do here called add the inverse. Inverse means opposite, so you're going to add the opposite of negative 110 is positive 110. That's it. And the question, what number belongs, blah, blah, blah. If you want, you could just write the expression slightly larger so that it makes sense, and that's exactly what it looks like. All right, let's keep going. Okay. So something I've been doing with this one is just kind of making sure that we're understanding that when we have a variable and a number multiplied by each other, just like peanut butter and jelly, you just stick them together. All right? So one thing I'm going to do here is this is ultimately going to be 48y. Okay? So we have to solve what's in our parentheses first. Y times 40 will be 40y plus 8. That's not going to work because 40 has a variable, but 8 does not. We can't combine unlike terms. So F will not work. G, parentheses, we do 4 times y, which is 4y, but on the outside of those parentheses, we still have 8. So that will be 8 times 4y, which gives us 32y. These are clearly not the same numbers. So G will not work. Y times 40, that's going to give me 40y, plus y times 8 will give me 8y. These are like terms. These I can combine. Boom. H is our answer. For this next one, they want us to go step by step, which is not a big deal. All it's doing is telling us what we already do anyway. But this is a little small, so I'm going to write it bigger. We have 2a plus 3 times b plus 4a. All right? Literally can't do anything here, can't do anything here. But they say they want me to first show distributive property. Remember, distributive is giving out a number to be multiplied. So I'm going to give my 3 to my b to be multiplied, and I give my 3 to my 4a to be multiplied. Then I just bring everything down. I have 2a plus 3b plus 12a, because 3 times 4 is 12, and then you add your a. Now, you heard me earlier say something about like terms. Those are terms that have the same variables. So 12a plus 2a is 14a. I can't do anything with my 3b, so I just drop it, and that's my answer. Looking at 22, again, they want us to evaluate, which just means we are solving, but they want us to evaluate the expression for 6x equals 6. That means that we're going to be placing this 6, or substituting that x with that 6. So, let's do it. I'm going to rewrite my expression. Remember, not minus x, minus 6 plus 4 squared. Now, let's get to solving. Parentheses first. 28 divided by 4 is 7. And then I drop everything else. Times 5 minus 6 plus 4 squared. Next thing I do. Exponents. 4 times 4 equals 16. I drop everything else. Plus 6 minus, there's the 5, multiplication, and the 7. Now again, PEMDAS says I should multiply first. This is going to give me 35 minus 6 plus 16. 35 minus 6 will give me 29, and 29 plus 16 will finally give me the answer of 45, which is exactly what I need. All right, let's keep going. Which expression is equivalent to 30 divided by, and in parentheses, 3 plus x? Okay. This one comes off a little bit as a trick question, but it's not that tricky. Here, all they did was get the 30 and move it to the end. We can't do that. That's not going to give us the same answer ever. But there's something going on here, and there's something going on here. The only thing that's happening is that the number is moving. It's commutative property. But if the number moves, it's not going to change the outcome of our answer. So what if this was 2 instead of x? 2 plus 3 is the same thing as 3 plus 2. So G is going to be our only equivalent answer. The other ones don't make sense. J added an extra 30, not sure why. H, they moved the parentheses, which completely changes our answer, not sure why. And that's why it's not equivalent. Okay, here. We are distributing our 9 to our 6 to be multiplied. That's going to look like 9 times 6. We're distributing our 9 to our x to be multiplied. That's going to look like 9 times x. These are equal. They work, okay? But we need to talk about the other ones too. This would be 72. So this would be x plus 72. This would be 9 distributed to all of that, so that would be 9x plus 72. And those are not equivalent. That's wrong. That would be 48 divided by x. 48 divided by x. This would be 8x divided by 6. Those are also not equivalent. That is not correct. This would be 6x plus 3. This would be distributive. 6x plus 18. That is not equal. That is why it's not equal. 25. Shay wrote an expression, 5 times y plus 2, in parentheses, plus 4, to show the amount of money 5 friends paid for snacks at a baseball game. Cool. Which expression is equivalent to the one Shay wrote? So again, I'm looking at my answer choices, and I see that there's a bunch of 5 times y, 5 plus y, 5 times y. So they really don't want us to solve this. They want us to break it down. I know I'm going to be multiplying my 5 times my y and my 5 times my 2. 5 times y plus 5 times 2. And don't forget about your tail here, plus 4. If I look at my answer choices, F is immediately off the table because they're adding everything. No. G, I have 5 times y times 5 times 2. Are we multiplying? 5 times y times 4 plus 5. This one is completely all over the place. 5 times y, yep, plus, yep, 5 times 2, yep, plus 4. This is our answer, guys. All right, for the sake of time, I kind of have to go quickly here, so I apologize, right? But if I were to decompose 36, I would get 30, and I would get 6. And if x is being multiplied by it, then it would be x times that plus x times that. That works out right here. Another one that works out is 4x times 9. This would be 4x times 9, which gives us that 36x, which is exactly what this one equals as well. Boom. All right, I'll tell you that one doesn't work. Immediately, it doesn't work. Let's solve PEMDAS even inside your parentheses. We have 2x, 8 minus, and 3. 3 gets distributed to the 8, that's 24. 3 gets distributed to the negative 2x, that's negative 6x. Closest thing we're going to get to that is this one. So on the inside, we're going to write 3x minus 2 times, or 8 minus 2 times x. And we're good with that one now. 24. So this is what? Negative x times 3, negative 3x, negative 3x. That one's not hard. By default, this is our last one that goes in. But it works. If I do this, that's 3x minus 24. And that's why that works, okay? Awesome. Almost done. Okay. Here, we saw this earlier. This is adding the inverse. So we know all of our numbers are positive. So if every single one of our numbers are positive, and these are our only two answers, I can't choose a negative. Now you'll notice they have parentheses, 11 plus, and then parentheses here. Let's rewrite this a little bit differently. We know we're working with 10. Now let's use our brain, guys. 10 is being distributed to my 11. 10 is being distributed to another number that's supposed to equal 200R. That other number is going to be 20R. And I can prove it by literally just solving it real quick. 10 times 11 is 110, plus 10 times 20, R is 200R. And that's how I know it's true. All right, last two. Good God. Okay. It's easy for us to look at this and say it's 100 times 100. But if we do that, then what we have is this. Is 10,000 the same as 100? No. So we know we can get rid of our 100 squares, which means that our only other option is going to be 10 cubed. Perfect. 10 cubed. But now let's figure out the rest, because the rest is not tricky, but still more work. 144 decomposed. If I put it into two different numbers that can, well, one number that can be multiplied itself to give me the product of 144, it's going to be 12. Now, how many 12s do I have? I have two of those 12s. And that's exactly what one of our answers is. But now we're going to continue breaking this down. I'll just rewrite it. 144, 12, 12. I can break it down as 2 times 6, which is 2 times 3. 2 times 6, which is 2 times 3. Circle my prime numbers. 1, 2, 3, 4. That's 2 to the 4th power. 1, 2 times 3 squared. And I have my 10 cubed anyway. Now, for the sake of time, 3 cubed plus 4 squared is going to be here. 4 cubed plus 3 squared, or times, sorry, not plus, times, my bad, is going to be here. 3 squared plus 2 cubed is going to be here. And our last one is going to be here. All right. Hopefully this helps, y'all. Where's my mouse?